Science fiction has long dangled cool visions of technology in front of us. And now, while over the years we've got some things down handily, like televideo phones and, say, leaving the planet, plenty of that future is still ahead of us. Artificial intelligence, specifically, promises to propel us on our way to some of those visions. Are we getting any traction with AI in the cyber domain? I wonder just how much sci-fi is involved with it. Will it be easy, like, say, flying cars? Or perhaps more difficult, like teleportation? Whichever the case, the newness of AI causes justified concerns about rushing it. So for the near term, we expect AI to stay on a leash. Recently, we read about an Air Force-sponsored AI soundly defeating a human adversary in air combat simulations. And interestingly, the Air Force is mainly talking about how AI can complement a human pilot. Likewise, the Army AI Task Force highlights the augmented side of their future AI spectrum, where processes bolster a warfighter's capabilities. Hopefully you caught my colleague Carol Smith's talk yesterday on the subject of AI ethics and understand why people want to be careful about rolling out new intelligent processes. All this means that human operators will leverage an AI technology as a subordinate, if not as a peer, in new teaming constructs. Can we envision that sci-fi future where cyber operators have the aid of processes that are both aware of the mission and have ample experience to act, or at least recommend action? Well, we have a lot of questions to ask and answer in order to make that happen. Where in cyber operations will AI be useful? Are there cyber tasks as straightforward as a dogfight, acquire, maneuver, and stop a foe? Certainly anomaly detection has been around a long time. Can it be made better with access to a broader scope of data? More specifically, can automatic correlation of disparate data sets find patterns and draw conclusions that significantly accelerate cyber domain decision making? And can we even generalize cyber operation tasks sufficiently? Though we're still working to frame these questions, we at the SEI are excited about teaming AI entities with cyber operators. In this talk, I hope to both convey a direction to travel and to articulate the foundation from which we're setting out. Now, the SEI is particularly well suited for this endeavor with its collaboration of machine learning expertise and cyber operations exercise experience. People on these teams have significant background and experience to drive this exploration forward. One such team focuses on cyber workforce development, led by Technical Director Chris May. While in the past that term had a connotation of training, at the SEI it means cutting-edge applications in the cyber modeling, simulation, and exercise domain. Several years ago, I was here reporting on our success with U.S. Cyber Command's Cyber Flag exercise and how it really raised the bar for big force-wide exercises. Building off of our work to improve and scale hands-on cyber exercises, we transitioned a platform that published the state-of-the-art forward for the DoD. And we've continued that momentum by improving our tooling and applications to make even more realistic environments. That evolution has produced artifacts that can be leveraged for data set generation and AI test beds. The SEI has also cultivated relationships with stakeholders interested in the advancement of their cyber workforce. We appreciate the collaboration of our partners. Access to and feedback from their cyber operator audience keeps us on track and relevant to their vision of what the force needs for mission readiness. If human-machine teaming is to be realized, significant applied research is going to need to be conducted. This research includes machine learning algorithms, to be sure, but it must initially understand what operators need AI to do as part of that organic-synthetic partnership. So with that combination of internal teams and external partners, we're setting out to produce formalized data sets. Now, cyber exercises can be great data generation events. They produce a good ratio of normal and abnormal activity, and often with anonymous or clean artifacts, logs and captures that can be shared readily without running into a lot of policy roadblocks. And since an exercise is a somewhat controlled event, they offer some deterministic events. That's one advantage over pulling a set of, say, live real-world data. So exercise-generated data sets will be helpful to people asking those sorts of cyber AI kind of questions. Following this talk is an overview of the President's Cup cybersecurity competition by my colleague Matt Carr. A data set resulting from such an event as that could be a rich trove showing how a wide variety of humans tackle complex cyber tasks. Participants in that competition hail from many government departments, the bulk of which are from DoD, and have many variety backgrounds. Some folks are just starting out in their cyber career, and some who can really be considered elite. The challenges given them are compiled from the full spectrum of cyber tasks. In fact, those challenges are mapped to tasks and roles defined by NIST in the NICE Cyber Workforce Framework that they publish. Now, with these types of events, we have a real opportunity to develop models of cyber operators that formalize the state spaces of the domain. And defining those state spaces is going to be necessary to transform a heap of exercise data down into efficient data sets. What would that look like technically? Years ago, and perhaps ahead of its time, we explored the idea of automated cyber evaluation. The goal was to have a process watch an operator's screen and grade the execution of certain tasks. It was used by computer vision to look for solution cues that were designated by subject matter experts ahead of time. The competition challenge is a great variation on that theme because the challenges have clearly defined and graded endpoints, and we can capture how a variety of humans behave in that world and separate out the actors as well as normalize all of the actions. Then we can take all that data, the approach and methods of all the different participants, and feed that as a learning algorithm to a learning algorithm as training data. With that next step vision in mind, allow me to describe some of the tooling that can serve as a foundation to build on. Standing up infrastructure and configuring environments for this kind of data generation is not trivial. As production networks and services are complex, realistic models of them are as well. Add to that, they're generally ephemeral, so it isn't usually desirable to sink an inordinate time investment into getting them up and running. I mentioned CyberFlag earlier. When we were first selected for that effort, it was because we had creative and technical minds with good processes and applications. But it still took time, was troublesome to find errors, and truthfully required a lot of system-specific expertise. Since then, we've endeavored to reduce all three of those problems. And through that experience, we have promoted an infrastructure as code, as well as a DevOps approach to efficiently instantiating our simulation game spaces. Not only does this enhance the repeatability, improve the change management, and allow for easier transition, But it also abstracts the more mundane tasks of setting up the hardware and configuring the applications. This is a topic for another day, but our infrastructure as code applications are known as Crucible around here, if you want to follow up. But this approach to infrastructure allows scenario developers to focus on the creative aspects of delivering an engaging and realistic scenario. Now, toward that end, we're developing several modeling and simulation tools to achieve the goal of engaging and realistic. Now, my contention is that these data sets need to actually surpass the realism of live data. As I alluded to earlier, the environment needs to feel totally real, but it often benefits from some time compression and some anonymized resources, as well as those deterministic events. The effort to balance this leads us down the track of actually using AI processes to generate training data in order to train other AI models, which could be really cool down the road. An application suite we have named Ghosts provides life to a scenario by managing NPCs, or the non-player characters. These characters fill user roles and they generate activity so that a network has all kinds of normal and abnormal packets flying around, and so that logs and sensors have data to collect. We have a sophisticated NPC generation process. It really draws from many public sources to create these user profiles that could be real, but aren't. They're fictional. It populates this profile with all kinds of detail to include a credit card, an avatar picture, and even a personality that's generally expressed as preferences. Then in the scenario, the character generally acts in accordance with that personality. And the demographics are generated sensibly as well. If the scenario, say, involves military units, then we spawn NPCs with reasonable ranks, roles, as well as geographic attributes. Their addresses will be near the base at which they're assigned. And along with another tool, the Cyber Decision Analysis Simulator, CDAS, we can generate a scenario and a geopolitical context that merges real-world current events along with a fictional storyline. This all leaves us with a rich opportunity to inject AI processes into our exercise scenarios for added realism and ease of constructing this game space world. I'm imagining this: pushing a button and having a high fidelity internet spin up. It's instrumented for data capture with users that build social networks over time and who collaborate actively to accomplish their objectives. Oh, and then we can let some humans in to play along with them. We're headed toward that future. Now, the work we've done with infrastructure efficiency and scenario realism isn't only applicable to data set generation. It readily supports this concept of test beds as well. Realistic test beds are going to serve as the proving grounds for future breakthroughs in cyber AI. So it's feasible to generate a variety of data sets for learning and teaching a process, and then putting that process into a new, unseen before environment in order to test it out. So some of that high fidelity internet I mentioned comes from our gray box appliance, which is an internet in a box. It's called gray box because it projects the gray space in a scenario, usually represented as the cloud on network diagrams, or neutral networks not necessarily owned by the red team or the blue team. Now, that projection in gray box is a robust representation of the internet backbone, with nodes spaced geographically around the world, and even with appropriate latencies in between them. And so it serves like top-level DNS, it serves web applications, it serves mail. The reason I wanted to call it out here is because we're starting to use this existing work as a test bed for zero trust concepts and applications. And that's also a topic for another essay. But I wanted to suggest with that the potential of using mod sim and exercise capabilities, not only in terms of AI, ML, data set generation, but also as test beds for AI processes and other emerging focus areas. So I'll conclude by formalizing all of this a bit, leaving you with the research lines of efforts that we're considering. The first two go hand in hand: formalized data sets and formalized state spaces. Exercises are instrumented for data collection generally, but work needs to be done to integrate that collection into a cohesive picture. This would involve labeling, cleaning, and publishing data sets to some exercise data repository that researchers have access to. But in order to label that data, to make it clean, work needs to be done to understand those state spaces. And we think that with a significant operator telemetry set, along with the objectives that they're trying to accomplish and the ground truth data laid on top of all that, perhaps we can codify the states involved with cyber tasks. I think it'd be pretty cool to get a tool that transforms a screen recording of people in an exercise and boil that down into a matrix of numbers that can be leveraged for teaching an AI process to do the same sorts of tasks and make the same sorts of decisions. That would all set the stage for some analysis of where best to apply AI for the operator, and find out where it fits in that team. We'd like to discover the gaps as well as the priorities for developing those team processes with operators. And yeah, it would be great to know, say, what to tackle first and what would provide the most impact. And with an understanding of that state space, we can also grow a library of executable tasks that map to it. This can then be made available to autonomous agents to actually carry out the tasks that it determines are necessary. And while an actual autonomous operator would likely make a suggestion to its human counterpart, or at least ask permission before executing, it could be given a lot more latitude inside an isolated game space or a test bed, right? These ACOs, automated cyber operators, they need a place to grow from an infant to a toddler to elite. So with its concentration of machine learning experts combined with an experienced modeling, simulation, and exercise cadre, the SEI has a great foundation to explore the exciting future of this human-machine teaming in the cyber domain. The science is no longer fiction, and we're rolling up our sleeves to develop AI processes in cyber. We hope to continue gaining traction in realizing this sci-fi future, but only with its most positive connotations. Thanks for your time and attention, and I'd be happy to address any questions that you may have. Hi, everybody. We have a couple minutes for questions here, not a lot of time, but we wanted to have a quick discussion about this great topic. I have with me Dustin Updike. Dustin's an engineer on our team who's responsible for several of the tools we just got done talking about, specifically ghosts and several of the exercise assessments. So, Dustin, why don't you just kick us off with with your thoughts on how the tooling has developed and how you've integrated that into these exercises.
Thanks, Jeff. I think one of the exciting things that we've noticed over the last couple of years is that the tooling around extracting valuable data out of a large amount of a data set or something like that has really matured. And that's exciting because a big part of the problem is we have all these different data sets. How do we extract quickly what might be the most interesting information for our customers to use?
Yeah, so it's no longer just a here's a packet capture. It used to be that was like the output of an exercise. Here's a network packet capture. That takes you a little bit, but doesn't get you very far in terms of the holistic, events and injects and the user activity, operator activity that can put together a cohesive picture. And so, are you optimistic with that tooling being able to extract better information about producing a normalized data set that actually could be fed into machine learning algorithms, at least for classification decisions? Or?
Yeah, I think one of the difficulties of machine learning projects in reality is the speed of which you can operate. And so, if you have a large amount of data, if it's disparate, if it's something you have to get from different sources, that takes time, right? And that sort of takes the edge off of what that information might mean for operators in the field. And so I think it's easy to forget that the tooling that allows you to get at that data and process it faster can really help that project. It's not part of the output that you hand over, right? It's not the information that you provide that operators can use. But it's an important part, an intrinsic part of getting at that data and doing something with it. There's been a lot of open source effort behind that we can take advantage of and leverage, and so we've been looking at that, and we've been pretty excited about the leaps forward that people and organizations have been making in that front, for sure.
Yeah. It is exciting. I think it's a great pathway forward for us. Do you see any other questions come up in chat? I don't.
I have a question for you that we get asked all the time. How do you see the mixing of what we do in exercise versus what we do in real world ops in terms of data and how they can influence and touch upon one another? Have you given some thought to that?
Yeah, well, it is definitely a shame that oftentimes, training gets put by the wayside. But we liken the cyber operator mission to, say, the pilots or other industries whereby, those jobs that people are always training, right? They're rarely actually doing the mission, but they're always training for the mission. So, these capabilities, I think, get us a lot further to provide that same kind of live, if you will, experience where you have training events going on as part of your normal work responsibilities, and maybe sometimes not even highlighted as training. Maybe it's just seamless. So those kind of activities, I think, will continue to reinforce this, especially when we're talking about, integrating an automated partner in with a cyber operator, because as that entity gets more and more reliable and better at decision making, or at least presenting information for a decision to be made, then I think you're going to want to see that more and more being migrated from these test beds that we talked about into real world operations, again with that leash on there, so that we can kind of migrate this stuff out slowly.
It's almost as if you use that testing and exercise outcome to influence in the best ways what you do in production tomorrow.
Yeah, exactly. So we're about out of time. So let me just wrap up with Dustin. Your call on the science fiction part of this cyber operator augmented. Is it flying car difficulty, or is it teleportation difficulty? Are we going to be able to get to something in the next 5 years?
I think it's flying car in the sense that you still have an operator behind the wheel, right? And we can influence and provide information to the person actually making the calls and the driving.
Yeah, great. Thanks, everybody. If you want to, talk more about it, we'd love to engage in the conversation.